Good morning. You guys thought you were coming to the comedy session, didn't you? Yeah, that's later tonight. So, thank you for attending. What we're going to go through today is really what we find as suppliers of the industry. We have an opportunity to see a lot of different installations and what people are doing when it comes to data acquisition. What I'm hoping you take away from this are what are some of the benefits that you can achieve with your existing equipment, taking a look at some basic information, asking the people that utilize it what they need to do their job better. So can everybody hear me in the back all right? No problem. So when we look at the benefits of data acquisition, really probably one of the biggest ones is quick, easy access to information. It really strengthens your ability to take what your historical information is and put it present in front of your people throughout the whole process, whether it's maintenance, whether it's operational, whether it's the quality department, or even your customers. And when we talk about customers, you can't go very far when you talk about data acquisition without talking about the competitive advantages that it provides. For those of you that are commercial heat treaters, I can't tell you time and time again where having that sense of a data acquisition system and utilizing it and showing it off provides a significant benefit when people are touring in your facility. Probably one of the most underutilized segments when it comes to data acquisition is maintenance and support. Because I believe that in heat treating, everybody's very reactive. Okay, everybody talks about PMs that need put in place for equipment, but it still tends to be very reactive, and downtime's costly. So we're going to talk about some of the things that the technologies enable us to do as far as looking at baseline information and then making better decisions. And then, of course, when you have that information and taking it all in, that's going to be able to lead to energy consumption, furnace and equipment utilization, so you can look at statistics, you can summarize that information. That's going to turn into higher profits and lower cost. You can always find ways to do things better when you have that information. I thought it was funny when we talk about data acquisition in the 70s. Well, that obviously paper chart recorders. I don't know if anybody was at Conrad Kasich on the session before this, but with AMS 2750 Rev E coming out, there's a lot of changes. A lot of those paper charts are going away based off of the new requirements and what they're going to require for that information. But historically speaking, paper was a way that people actually gathered information, which limited us in a lot of the information that was available. After that, you have single data points. All right. In turn, what do you have after that? You have more data points. Okay. Now we're at the point where I have too much information. Right? And I tell you, everywhere we go that we're working with customers, it really is. It's taking all that information and how do you turn around and make it usable? So that's some of the things that you have to do. You really have to have a focused effort on making that information usable. The reason that we have too much information today is because of the technology advancements that we've seen. Really, the cost of sensors and the cost of the technology, the cost of computers has changed significantly. And as a side note, I kind of went online. I found this note, which I thought was really interesting. The cost of a gigabyte in 1980 was $193,000. And that's amazing. That to me is amazing, And that just goes to show what technology has given us the ability to do these days. Bringing a cost from $193,000 to 7 cents. So it's significantly different. But that's in every industry. It's not just the heat treating industry that obviously we all are concerned with today. So when you look at plant-wide information, the important thing is to have quick access to the information to the right people. I can't tell you how many times that if you go out and you ask the guys on the floor, you ask your furnace operators, what would you benefit from giving as far as information, what would they achieve as far as making their job easier or more efficient? Ask that question. That's one thing that people don't do. They make assumptions. Frankly, we make assumptions. We build screens, we build these HMIs and this information, but really what we need to do is work with our customers or your employees to find out what they want. What do they need to make their job easier and make them more efficient? And you really can break it down by department. I look at key stakeholders. You look at operations, you look at quality, you look at maintenance, and then you have the management team. All right, so what is the information that's important to those individuals? And make sure you're bringing that data to them. Historically speaking, data acquisition was very discontinuous. If you were to go out to a control room, you would see a controller, or I should say a control panel with a paper recorder specifically for that application. All right, and then you maybe have in that control room you'd have another place, very discontinuous. So that paper was not being shared with other systems. You couldn't get a holistic view on everything. So I put this slide up as even with paper, sure I can get that information, but how costly is that? How much does it cost to get that piece of paper from those files, copy it, send it to your customer? That's a lot of time. I put the quote on the bottom. We have one of our customers. I mean, this is directly from what they say is the old days of tracking down a chart, copying it, mailing it, or faxing it are a thing of the past, and I don't miss them. Who would, right? Who would miss that? Because it's time that your employees can spend doing other things. All right. Today, again, you look at technology and what you have access to, with a handheld device or smartphone or a tablet computer is really pretty powerful. But you have to figure out how you're going to utilize that to make whatever operational information or the key stakeholders how are they going to benefit from that? So don't just put it in there just to have it. What are you going to benefit from it? How are they going to drive lower cost or higher productivity or whatever it might be? Jay Kasich went through all the AMS 2750 Rev E stuff in the prior session, but there's a couple things that I think that you need to recognize. Even if you're not NADCAP, this trickles down to all industries. When you look at pyrometry and some of the points of pain that people have had in the past, now they're getting into defining more information around electronic requirements. So they actually have a definition for an electronic record. When you look at the electronic record, there's three things that I like to highlight. It says electronic records that cannot be altered without detection. It's a very important component. The system and software shall not provide any means of altering the source data, so you have to have that. And then the system shall be capable of providing evidence that the record was reviewed. That's a big one, all right? Because right now, if you think about traditionally what people are doing, they take a paper recorder, they're writing information, or they're having a signature, they're proving that they actually looked at it, all right? So you need to be consider how you're reviewing those paper charts moving forward. Other things when it comes to data acquisition and what you should know, you need to look for an open architecture. There is a lot of different tools out there that you can utilize. There's a lot of communication architectures that can be used. So you want to make sure that whatever you do, you have access to get that information multiple ways. You should look for quick, easy data retrieval. So you want to make sure that the information can be gathered quickly, and then you can review it. So you're not having to flip through a lot of different files. It comes up slow. You want to make sure that it's really easy to use. Data compression techniques, I think this is very important because it ties into how fast that information can be retrieved. And of course, easy to use and maintain. Nobody on the heat treat floor is an IT professional. All right, so making sure that it's easy for people to use. You want to be able to click on a button, put in a date, render a chart or render a tabular data, print it off, put it in a PDF file, whatever it is. Make sure whatever your desire is, make sure that the system has those capabilities in place. When you look at the data layers, you have multiple levels of data. I kind of break it down into field devices, control systems, and shop management. Shop floor management, that's your Blue Streaks, your Cornerstones, your SAP, your Oracle. So you take it down one level, then you're looking at control systems. Those might be PLCs, those might be some of the multi-processing controllers, it might be just discrete controls, and then you have field devices, sensors, thermocouple inputs. There's a number of different things that you can kind of break it down. But really what you're doing is you're taking advantage of all those discontinuous control systems and sensors and bringing them centrally into one system. And there's different ways to get that information, different communication protocols that can be taken advantage of. So when you look at your different ways to acquire data, as far as getting the information, you have things like your analog to digital, just pulling an analog signal. Take a thermocouple, for example. Jumpering that information, turning that into a digital information that you can put on a chart, or you can look at it in a tabular format. Or you can use communications. All right, if you're using communications, a protocol that you can actually talk to those discrete controllers or to the PLCs or whatever the control system is, there's a significant amount of information that can be gathered from that and then utilized for other things. Now, when you're thinking about these things, I always think it's important to look at the industry requirements. If you take the pyrometry guide, touching on the AMS specification again, you really need to look at what you're investing in. What does that mean when it comes to things like calibration, where you actually have a temperature controller here with a thermocouple that's hooked up to it. You have a part temperature here using a load sensor. These are 2 calibration points, okay? You might have a third calibration point depending on your approach to get that information onto a data acquisition system. Now, there's 2 ways to do it. You can either do it using a thermocouple extension wire, taking it into some other type of analog to digital information, or you can use communications. If you're using communications, you only have 1 calibration point. So at the end of the day, what you're looking at there is that additional calibration point turns into cost. All right, so now you have that component that you have to look at. The other thing when you look at analog to digital, as far as gathering that information, you have to look at long thermocouple extension wire runs. I've seen facilities that they tie all of their load sensors and control sensors into one central location with extension wire. It works. It can be done, but that creates a potential for voltage drops as well as noise over the lines. So there's multiple ways to do it as far as getting that information. Another reason to use communications is to get away from that. So you're using communication to talk directly to the control instrument to gather information from there. So why do that? Well, you look at a couple things. All right, if I'm talking to using communication protocol to gather information from an instrument, I could be using RS-45 or Modbus communications, and I'm getting not only what the actual temperature is, but I'm getting the set point. I might be getting the percent output. I'm getting all your I/O associated to that particular control. You might also be able to take the additional program information. So if it's actually running a recipe, all of that information can be brought in. So that's valuable information when you're looking at taking advantage of not just producing a chart for the quality department, but now you're looking at troubleshooting from a maintenance standpoint or looking at the operational statistics of a controller. So when you look at communications, there's a couple terms that are common out there. RS-45 or Modbus or twisted pair, it's commonly referred to. It's been around for a long time. It's a proven method of gathering information from controllers, and frankly, most of the instrumentation today supports this type of communication protocol. They can go on 4,000-foot runs. I'd say that probably every facility that we visit has instruments out there that would support this type of capability. And again, it's proven technology, and there's no reason why it can't still be utilized today. Ethernet is another one. It seems that more and more people are driving towards Ethernet-based communications. Again, you're still getting the same amount of information that you're pulling out of these control instruments. So you got to look at things like switches and hubs and managed switches, because all of a sudden you're introducing that controller and your data acquisition system potentially on your existing network where all your other computer traffic is. So things to think about is looking at managed switches. A managed switch is a smart device. It means you're looking at the data traveling through one point to another point instead of introducing it to all that network traffic. So, those are some things and strategies that certainly need to be considered when you look at the going to with a communications protocol or Ethernet. And of course, there's wireless too. So there's a lot of people that are using wireless. You can use a wireless that's a serial communication protocol, or you can use wireless that's Ethernet. Control Engineering Magazine always puts out, it seems like an article every month about wireless Ethernet used on a control or in the manufacturing environment. So people are using it. There's no doubt about it. Of course, you need to make sure it's going to work in your environment. So that's something that needs to be considered when you're looking at that. But I can tell you right now that there's existing installations in a heavy noise manufacturing environment that is using communications, wireless communications successfully. And there's no reason why you can't use all three of these. Whatever the controller support, whatever your network infrastructure supports, build on that. So when you're looking at data acquisition, distributing that information to the right people. Okay, the more people that get at the right information, the better decisions they can make. And if I look at operations, what's important to the operations department? Well, the current equipment status, load planning, or cost per load. Now that might be something that belongs in the stakeholder of operations. Quality. When you look at the quality, what's important to them? Well, industry specification, customer requirements, being able to show proof of process, print a chart, email a chart. Those are all things that are absolutely critical. And then maintenance, preventive maintenance. How can you be preventive instead of being reactive, right? That's the goal potentially from a maintenance standpoint. And then, of course, you look at things like TUS, looking at the temperature surveys. How can I better utilize that data? In getting that information, or even calibration reports. Does the data acquisition help you with your ability to do that as well? So from an operations standpoint, you want to be able to provide a summary. You don't want to look at that chart and just pull up a chart and show this information. You want to be able to look at current running information, possibly, statistics on how a shift is performing. You want to look at maximizing your equipment by looking at potential for making sure I have loads ready to go into a furnace. The other thing is shift planning. How can you better plan for shifts? Again, I like to use a quote from somebody that actually utilizes. We have quote being we have been able to streamline our processes by using real-time electronic data. We now have an opportunity to manage production instead of chase information. It seems like basic stuff, but implementing it so it works for everybody is the key to making that successful. Here's an example. This is actually a customer that they were looking at their summary of information, looking at the overall results of overnight runs. Okay, so based off of the third shift. So what they're trying to do is get to the bottom of why they had a 5.5-hour gap in between loads. Okay, what was the problem? Were they not staffed properly? Okay, so you can look at that stuff. If you have to look at a chart, it's going to take you a while probably to kind of gather that information. But if you can summarize it properly and then just have a quick view in it, that's where the benefit is. So other things from an operations standpoint, and I do think that one of the things is a takeaway from here. I think asking the operators what they need to do their job, what information do they need to do their job better, you'll see a benefit, because at the end of the day, I really think that everybody wants to perform to a level above where their expectations are. All right, if you give them that level, okay, and you produce that, you show it to them on how they're performing, even if it's in real time how they're performing, you'll see productivity increase. And that's not me just saying that. That's from customer experiences based on finding out what people feel they will be better as far as gathering that information and how they can do a better job for them. So give them their current operation information, operational results as far as what's my productivity performance at this particular time. The other thing is time till time till load's complete. If you have some type of a recipe program or something that you're actually running in a process, if you have a timer, show that timer. Provide that on a big screen out on the floor. The cost of a projector on a wall, the cost of a big screen TV. Get that information in front of them, because if they know they got 6 minutes before before the load quenches or coming out, they're going to be ready for that. So that's what you want to do as far as putting the right information in front of the people from an operations standpoint. Operations, the other thing when you start looking at the information that you can gather is electrical energy. How can I gather more information? What about your kilowatts? And if you start looking at this and start looking at things like peak demand, so what's my overall facility usage? You can start doing things, and there's a number of systems out there today where you can actually start cutting back or deciding on, maybe I'm not going to run a load at this particular time, or maybe I'm not going to quench it, or whatever it might be. But if you're getting close to that peak demand, you can monitor that using things like current donuts and then devices that'll give you what your totalized kilowatts are, your current kilowatts. And you can do that at a facility level. You could do it on a per equipment level. You start breaking it down to the lower levels. Now all of a sudden I can get cost per load. And we start talking about things like that. You also have the ability to gather information, use it with gases. So how much gas usage, whether it's processed gas or heating. So those things are all out there today. And you start gathering this information. And again, I go back to, is it too much? Well, you decide. You decide where to make that investment, so you're getting the information that you can make better decisions. When we look at quality is kind of an easy one. You have to have traceability. So your customers are going to want to be able to look at their loads and look at their charts. You look at your customer requirements, the industry requirements. You want to basically give them that process data. Not too much information. You want to give them just the right information, right? We have many times customers looking at a chart. It's got percent output on there. It's got this. It's got that. All they want to know is the temperature, that the process ran in, which is fine. Make sure you have the flexibility to do that. Make sure it's easy. Make sure you can email it. You have some mechanism so you can do it electronically, because there's a significant benefit there. When we look at things like preventive maintenance, you really want to basically reduce unplanned downtime, bottom line. All right, what was my baseline? What did my process look like when it was running? So looking at a couple things that you can capture when you look at maintenance. Temperature is a big one. If I look at my water inlet and my outlet, I can identify a pattern. Okay, it's very easy to monitor some of these. These are just simple data points. And you can alarm on this too. So if you know that I'm trending in one direction or another, you can then identify that maybe my pump's getting too hot, or maybe I have scaling buildup in my cooling jacket. So there's a number of things that you'll see that flow restriction. You'll see a rise in the outlet temperature. So you obviously are identifying a problem. Looking at things like vibration. Vibration monitors today, that they're low cost. They're actually very easy to install. They provide 4 to 20 input into an analog input, where you can actually then start monitoring it. If you start looking at some of that information, it's going to take time to create that baseline. All right. Once you create that baseline, though, if you look at something like vibration, you're going to find, well, maybe I have a fan that's out of balance, or maybe I got a motor problem. So there's a number of things that you can do as far as looking at that baseline, being able to react on it. All right. So instead of waiting for that catastrophic failure, okay, and then you got to wait for parts, and now you got downtime in the furnace. All right, now you have some additional information, that baseline, so you can utilize that. So just an example where you can investigate. This is just a recent example. I had a customer call up and said they couldn't get a straight line as far as control. Well, looking at their situation, they had an output limit on their controller. Well, all you had to do is look at the percent output, which is on this chart, and you can see that flat line in the middle. That flat line was limiting the percent output to 50%. It took less than a minute to find that issue, and then the only reason that they had that is because they changed the properties of the furnace, or they went through a TOS, or they changed the elements. I can't remember what the issue was. but they had a limiting factor on their percent output of the control. When you're looking at some other things, you could do gas analysis. When you're, we talked. There's a number of different talks on atmosphere troubleshooting and looking at things. We get phone calls all the time. What is my 3-gas reading, IR gas reading for my endo generator? Well, you start to ask some questions. You start to see that the methane is creeping up. Well, methane's creeping up. Well, there could be one of two things. I mean, is the generator at the right temperature? Or is my catalyst going bad, or maybe it needs to be burnt out. So you can see that because you have a base. Now, if you have that baseline, you use that 3-gas analyzer, you know what your atmosphere is supposed to be like out of that endothermic generator. On a furnace, when you're troubleshooting a furnace, if you start looking at the atmosphere in that particular furnace, if you're having a problem, you shut off the gas, the enriching gas and dilution air. You run just straight endo into that furnace. All right, that should be pretty close. All right, you can only do that if you have those additional inputs that you can create that baseline. But it certainly helps with troubleshooting. A couple other points when we look at some of the troubleshooting topics or looking at maintenance. Oxygen. When we look at protective atmospheres, there's a couple pieces that I want to look at here. When you look at radiant tubes where you have a crack, you're going to be able to look at a probe and look at the millivolts of a probe, and you're going to see that I have a tube leak or a crack in the tube because the millivolts are going to drop. All right, which means when millivolts drop, you go to high fire. Okay, so that on that tube you go to high fire, millivolts start to drop down. Well, all of a sudden I can see that now I'm throwing a bunch of gas in there. So all of a sudden you have an uncontrollable process. But that's just an example of additional information that maintenance can utilize to troubleshoot a problem. Damien, who was on earlier, he touched on this as well. Another opportunity for capturing information. I use this Department of Energy slide. Minimizing combustion air can deliver 35% savings. So what you do is you measure the oxygen in the exhaust gas of your burners. When you're measuring the oxygen in the exhaust gas, you have an opportunity to create higher levels of productivity for that furnace. You're basically increasing the heating capacity. So if you look here, this is a case study. This is a chart where a furnace goes on high fire. You're looking at the O2 as a percentage of as a percentage in the exhaust gas, and the benefits are tremendous. You can look at your heat up rates. When you're just looking at the products of combustion where you're 5% air in your exhaust gas versus 2%, your time to heat on these same examples went from 65 minutes to 49. That's 15 minutes per load. All right, 15 minutes per load. You start looking at how many loads do I run a year? How many shifts do I have? That's money. That's real money. Whereas you're looking at as a byproduct of that, you're also getting gas savings. All right. So those are some operational improvements that you'll see as far as understanding that. And these are, in this example here, these are sensors that are installed. They're Lambda sensors that are installed in the exhaust stack of the burners.